Polynomial functions. So our fourth unit here is on polynomial functions, their graphs, their behavior, that sort of thing. So step one is what is one? What is a polynomial function versus what is not one? Well, the x's have to be to a positive integer or whole number power. Now, the number in front of the x could be a decimal, could be positive or negative, it could be a fraction, that doesn't matter. It's the powers. Notice every x has a positive whole number power, and it can have just a number. This is okay, this is okay. These are all polynomials. These are not. The x has to be a regular x. The x cannot be in the denominator. You cannot, see, this looks good if there was no square root, but you can't have the square root of x stuff. You can't have x's to fractional powers. You can't have x's to negative powers. You can't have x's to decimal powers. It's got to be nice, whole numbers, positive ones, and no weird stuff like square roots or trig functions or anything like that. So that's what a polynomial function looks like. There's certain things about the polynomial function that is important. So there's something called the leading coefficient. Now the leading coefficient is the number in front of the highest powered x. So in this case, it would be 2/3. In this case, it's 0.3. In this case, it's an understood 1. If there's no number in front, there's a 1 there. There's also something called the degree of the polynomial. Now the degree is the largest, power x is raised to. So this one is degree 3, this one is degree 8, this is degree 11. It does not matter what any other x's are raised to. This is the dominant term, and all we care about for degree is the power of that, the highest power, and the leading coefficient is the number in front of the x for that highest powered term. Okay, so that's the vocabulary. What about them? Well, we get this grid. I'm actually going to get rid of these examples because we're going to do some more in a minute here. So let me make this larger. What we're focusing on is the polynomial function graphs at the moment. So we want to make this 2x2 matrix. So this, I'm going to put leading coefficient is greater than 0, which means positive, and leading coefficient is less than 0, which means negative. And this is even degree, and this is odd degree. So in a minute, we're going to be looking at some equations, and we're going to want to think about this grid. Now, if it's, actually I want to reverse this. Let's make this odd and this even. Now, with the exception of lines, which are technically an odd polynomial, odd degree polynomial, these look something like this: a cubic function, or basically a cubic function with a squiggle in the middle. Now, you can have multiple squiggles if you want to call them that, but notice how it starts low, ends high, kind of has that same look, although, you know, I'm playing around with the middle part there a little bit. Or it could be the reflected versions of these. So that would be if it's odd degree, it's one of those two. And this is if it's a positive leading coefficient. This is negative. So I'm just going to write it that way. Positive leading coefficient, negative leading coefficient. Now for the even ones, those are either parabolas or modified parabolas. So if it's a positive leading coefficient, it looks like a parabola, or it could look like a W shape or a skewed W shape. Could have multiple squiggles in the middle. Basically, if you think of this as a string I was holding up and I picked up the middle, see how it would do that? So those would be positive leading coefficient, even degree, and if it's a negative leading coefficient, it looks like the reflections of these. So upside down parabola, an M shape, or a skewed M. So that is important. You're going to want to put that in your notes because as I move through the material, I'm going to keep referring to this, but I have to erase it so I can do some examples. So if you want to, pause it, put this in your notes. Okay? So I'm going to erase this and make a tiny version of it up in the corner. It's not going to be big enough to really see, but you'll have it in your notes hopefully, so you can kind of look at that for more detail. So we have this shape, or these shapes, the parabolas. I'm just going to abbreviate it with a couple of these. Right? So that's kind of the gist of it. So let's look at an example now. Suppose we had y equals x cubed plus 3x squared minus 4x plus 1. Let's do another example. Y equals x to the fourth. Let's make it negative minus 5x plus 2. Now we're not worried about every detail. Basically I want to talk about something called end behavior for these two examples. So notice end behavior meaning E-N-D, end behavior. What's going on the left end of this graph? What's going on the right end of this graph? So look at these odd degreed polys. The end behavior is opposing, meaning one end goes up and the other end goes down, or vice versa. So whatever direction one is going, the other end is going the other direction, right? Like this or like this. For the even degreed polynomials, notice the two ends are going in the same direction, either both up or both down. I don't care, here, both up or both down. It's not, I don't care what it's doing in the middle, I only care what it's doing at the two ends, the left end, the right end. This is an even degreed polynomial. This is even degreed. This is odd degreed. This is odd degreed. So it's the end behavior. So if I look at my example, I see two things. I see that this is a positive 1, which means it's positive leading coefficient, and I see it's odd degree, so I know that narrows it down to this column. So in this particular case, I wouldn't know if it looked like that or if there was a squiggle in the middle. That's not our concern. What I do know is it's got to start low, it's got to end high, and either I'm just going to connect them or do something like this. We're going to talk about that in our next example. I want you to focus on the end behavior. Because that's positive, because that's odd, the left end has to be going down and the right end has to be going up. That is important. Now for this one, it is a negative leading coefficient, so now I'm looking at this row, and it is an even degreed polynomial. 4 is even. So it's got to be one of these pictures. I know the left end has to be going down, I know the right end has to be going down, and I just don't know what's going on in the middle. If you want, you can punch this in your graphing calculator and take a look for yourself. So I'm just going to, who knows, let's just kind of guess, maybe it looks something like this, right? What our focus right now is, what is the end behavior? And in this case, both ends are going down because of these two reasons. Negative, even. Okay, so now what we're going to do is later in this unit, we're going to factor these and break them apart. So I'm going to give you some problems that are already all factored, and we have to see, how do you tell, well, how do you get more specific about what the whole graph looks like besides just the ends? All right. All right, let's start with example 1. All right, now you might think that this looks completely different. You do not need to record this. I'm going to show you how this is the same stuff. I'm just going to zip through the algebra here. See, this would be the same as I have 3 things being multiplied. This is a FOIL problem, which is going to work out to be x squared plus 2x minus 3. And I still have to times it by that. This is not what we're doing. I'm just showing you. So then I got to multiply everything in here by everything in there. So this is going to be x to the third plus 4x squared plus 2x squared, 8x minus 3x minus 12. So this is x cubed plus 6x squared plus 5x minus 12. See? That's the same kind of thing we were just looking at. It's just this is all factored. I'm doing that to make it easier for you because to factor that is going to be challenging. A lot of you struggle with factoring quadratics if this is just squared. So we're going to deal with that later. So we don't need, this is not our focus. We don't need to know about that right now. We're looking at this. All right, now what I see here, to get the leading coefficient and the degree, you got to focus on these 3 things. If I multiplied those 3 things out, I would get x cubed. That is my dominant term. That has a positive leading coefficient, and it's odd degreed. So that tells me my picture is going to be like this or like this. I don't know which. Now, there's something called zeros. So for zeros, what I'm going to do is set each one of these factors equal to 0. That's why they're called zeros. And I get these 3 zeros. Now, there's something called a multiplicity that's not going to make any sense to you in this first example, because all of these factors only occur once. They only have a multiplicity of 1, so that is going to make no sense right now. We'll worry about that in a future example. What I know right now is I know the leading coefficient. If I just focus on these first parts, I know the degree, and I know the zeros. So let me kind of pull this together. If I was doing this as an assignment, actually doing homework, I would write leading coefficient positive, degree odd, zeros are x equals minus 3, x equals 1, x equals minus 4. And for later reference, this is going to be multiplicity of 1. I know that makes no sense right now, but we'll just record it. See, this is all our given information, and we're going to transfer this onto a graph. The zeros are where the curve hits the x-axis. Or in other words, x-intercepts. Okay? So it has 3 x-intercepts, and that's going to have a big impact on our graph. I think I can squeeze it in here. All right. So I need to scale my x-axis. We really don't care about the y-axis. We're just trying to get a sketch here. I know that this graph has to hit the x-axis at minus 3. That's this 0. Positive 1. That's this 0. And negative 4. That is this 0. Furthermore, I know it has to, because it's one of these pictures, it has to start low and end high. Now what's going to happen here is I'm going to have to go, I'm going to go up here. See, you got to swing down and hit that 0. and then I'm going to dip down, and I got curve up. See your, how should I put this? You start with your zeros, then you put your ends in, and you got to look at the grid to know the two ends. And then let me retrace my steps here. That's what I know so far. Now this has to be one of those shapes in your grid, so it's got to have those hills and valleys. So I'm going to go like, that's got to be a hill. It would not look right if I did this, right? That does not look right. So it's going to have to go up and then down and then up, and that completes my picture. So it's a little bit weird, but you get used to them. We're going to do another example. All right, example number 2. All right, so I look at this, and I look there, 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 and there, and that would be x to the 4th for my dominant term, and I see that that is a positive leading coefficient, and it is even degree. Now for the zeros, I'm going to look right here. My first 0 is x equals 5. Second one is x equals minus 4. That one a lot of people miss. They skip over it because it looks different, but that would be x equals 0, and this would be x equals 7. So this one has 4 zeros. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6. Don't really care about y-axis for these graphs. So now I'm going to place my zeros. I have 1 at negative 4, 1 at 0, 1 at 5, 1 at 7. So let's see, if I look back in my grid, I see even with a positive, that is a parabola or W shape. So it has to go up on the left and up on the right. And in the middle, I got to somehow weave in and out to complete that picture. So look at it. I'm going to go down and then up and then down and then up to complete the picture. Now, usually it's normal at this time to wonder, does it matter how far down, like if I did this, would I be wrong? No, these are sketches, not precision graphs. So what I'll be looking for, like when you take a test, is the correct general shape. I will not be looking how far down. We didn't even scale it. I'm doing that on purpose because I don't want you to focus on that. All right, so now we're going to get into multiplicities. Now this one I didn't write it, but all of these have a multiplicity of 1. What does that mean? It means I see each one of these factors just one time. And that probably means nothing to you. You need to see an example where it's more than once. It's compare and contrast. So let's do example number 3. All right, you see those squares. What does it mean to square something? It means multiply it by itself that many times. So you don't have to write this. You just need to see it in your mind. See, I got 2 of those. That's a multiplicity. 2 of them. 1 of those, multiplicity of 1. And 2 of those, multiplicity of 2. So what does this mean? I have 1, 2, 3, 4, 5, or 2, 3, 4, 5. So this is going to be x to the 5th for my leading term. So my leading coefficient is positive 1. It is odd degreed. Now the zeros, there's only 3 zeros. X equals 2. X equals minus 1, and x equals 4. It just so happens that this one occurs twice, multiplicity of 2. This one only happens once, multiplicity of 1, and this one happens twice, multiplicity of 2. So I'm going to record that. So it's not a hard idea, but so what? Why do we care about that? Well, because if it's an even multiplicity, it bounces. And if it's an odd multiplicity, it goes through. And I know that's not how you spell through. So what does that mean? Well, we're going to go through the motions. We're going to do the same stuff. I have to erase this to have room for a graph. So jot that down. Three, four, five, six. 1, 2, 3, 4. So I do the same stuff. I have a 0 at -1, a 0 at 2, a 0 at 4. And this is a positive leading coefficient with an odd degree. That means it's either this or with a squiggle in the middle. So that means the left end is going down and the right end is going up. Now, the multiplicities start to matter. If it's an even multiplicity, it occurred twice, it bounces. What does that mean? Instead of going through that 0, it's going to bounce off of that 0. Not like a V in a U shape. Now, I gotta swing back up and hit that 0. So I bounce off of there, but I gotta swing back up. And I'm gonna check. 2. Oh, my bad. Let's back it up. So I put my zeros, I made error, sorry. I put my zeros in place, the left end is down, the right end is up. -1 has a multiplicity of 1, so I got to go through, not bounce. So I'm going to go through. And then I got to hit that 0, so I got to curve back down and hit it. Now the question is, what happens at the 2? Do I shoot through or do I bounce off? That's what the multiplicity does. I bounce off in this case. So I'm going to bounce off of there. Now I know I got to go up and then come back down because I got to hit that other 0. But what do? Go through or bounce? Well, it's a multiplicity of 2. That's even. So I'm going to hit the 0 but bounce off. And see, that's what I wanted to do because it's got to start low and end high. Let's do that one more time because I messed it up the first time. 1, 2, 3, 4, 5. 1, 2, 3, 4. I have a 0 here, here, and here. I know it starts low and ends high. This -1 has a multiplicity of 1, so I shoot right through it. I have to come back and hit that 0, so somewhere in between, right in the middle, I got to turn around and head towards that 0. The question is, what do I do when I hit this 0? Do I go through or do I bounce? Well, I look over here, that's why I write it. Multiplicity of 2, that's even, I'm going to bounce. So I bounce. Now that can't go up for infinity. It's got to go down and hit that 0 also. And it should bounce. See how it's got to go up? So that's even. It does. This is all working out the way it should. I go down and bounce, and it ends up going high just like I expected it would. I think we better do one more example, and then I'll let you try some. All right, our fourth and last example. All right, a lot going on here. So let's see, I see 2 of those, 2 more of those, that's 4. Another one is 5, and 3 more is 8. So x to the 8th would be my dominant leading term. So the leading coefficient is positive. The degree is even. And this has 1, 2, 3, 4 zeros. So let's make a list. X equals 0. A lot of people miss that one because it looks different. X equals -3. x equals 4, and x equals minus 1. Now we have to worry about multiplicities. So that occurs twice. This one occurs twice. This one is only once. And this one is 3 times. That's all the information I need. Now I'm ready to sketch a graph. Start with your zeros. Minus 3, 4, and minus 1. So let's see, this is positive leading coefficient with an even degree. That is a parabola or a W shape. So I know it's got to, on the left, it's got to go high, and on the right, it's also got to go high. In the middle is what we got to figure out. That's what all this multiplicity junk is for. So let's see, the first one I hit is minus 3. That's even, so it's going to bounce. So I come down, hit it, and bounce up. Then I'm going to have to curve back down and hit this one. The question is, looking ahead, do I go through the minus 1 or bounce off of it? Well, it's odd, so I'm going to go through. So I got to go up, turn around in the middle somewhere, and shoot right through. Now I know I got to curve back up to hit this other 0. The question is, what happens when I hit it? Do I go through or do I bounce off? And the answer is I bounce, because that's even. So I'm going to come down and bounce off of it. And now I got to go up, and it looks like I better go through. Let's check the multiplicity. That is odd. I do go through. Good. It's all working out the way I expected it. Okay, so we get kind of a strange, like a modified parabola shape in there. Try these for sure in your homework. Use your graphing calculator or Desmos to check your answer. Once you get the rules down, they're not bad. If you have questions, you can leave me a comment, or you can send me an email, and we'll address your questions. Okay, take care.